In this video, we're going to look at the composition of matter. So matter, of course, is anything that has mass and occupies space, and there are kind of all these divisions from there. And so we could go from matter into a pure substance over here or to a mixture. So a pure substance will be made up of only one thing. A mixture would have more than one component. So we'll just write over here one thing for my pure substance. So then we can break down that substance into either an element or a compound. So an element is just that single one element. They give the examples of sodium or hydrogen. Any element on the periodic table would count. And then a compound is basically just made up of more than one type of element. So it's still one species. Water is pure water. We could have, and it wouldn't be a mixture, but it's made up of hydrogen and oxygen atoms. So our compound is more than one element in a fixed ratio, like water, but it would still be a pure substance, for example, with water, because it's just water. Then on the other side, we can have a mixture. If we have a mixture, then we're going to have two or more components in our mixture. So two or more different species. Mixtures can be either homogeneous or heterogeneous. Homogeneous would mean, let me change colors here so we don't get too much stuff going on. Homogeneous just means it's uniform throughout. So if we look at a homogeneous mixture, it looks uniform throughout. So for example, air is clear and colorless, but it's not just comprised of one gas, it's comprised of many gases, and they are mixed uniformly throughout. So if we took a sample of air, it's going to be roughly the same no matter where we take it from. Salt water, like in the ocean, is going to be a mixture, but it's uniform throughout. So if we look at the ocean, it looks like one homogeneous mixture. If we think about a heterogeneous mixture, it's not going to be uniform throughout. So there could be layers, there could be two different sections, but it doesn't mix evenly. So oil and water is a good example. Those won't mix at all. You'll have two layers. Salt and pepper, we can kind of get those more mixed up, but we have, in the end, black spots of pepper and then white spots of salt. So those are not combined homogeneously. So in this picture from your book, we have three different examples here that we can sort of draw on the chart on the previous slide from. So in example A, we have a pure substance, water. It is a compound because water is made up of one oxygen atom and two hydrogen atoms. So this would be a pure compound, A. B would be a mixture, but it is homogeneous. So if we look at the flask, all we see is a blue clear liquid, and it looks the same everywhere in the flask, in the top, in the bottom, in the middle. So this would be a homogeneous mixture. Those blue dye molecules and those water molecules are sort of dispersed evenly and homogeneously throughout the mixture. And then we have some sort of rock here, and you can see that the rock does not look uniform throughout. There are spots that are white and spots that are black. So it is a mixture. It involves more than one compound in that rock, but it's not homogeneous, so it doesn't look the same throughout. So this would be a heterogeneous mixture. So there's some examples of what we mean when we say a pure species versus a mixture, and what we mean when we say homogeneous versus heterogeneous.